Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. The students, today we talk about the tree traversal. Okay. In tree traversal, we're gonna visit all nodes in a tree just once, and we're gonna do it very systematically. And then we do some operation on that node. Okay, and we carry on. And the tree traversals can be either pre-order, in-order, post-order, or level order. So when we talk about the pre-order, what we are actually saying is we gotta do first root, okay, then we say left, and then we say right. Okay, that's we visit the root node. Okay, then we recursively traverse to the left subtree and recursively traverse to the right subtree. Okay, so this is what we do here. For example, we start from the root. This is the root. So if it is a root, we're gonna write it down. Okay, this is what we say, start from the root node, write it down. So if you want to go for pre-order traversal of this tree, so we reach the root and we write it down, and we go to, after root we have to go to the left, because I said root, left, and right. Okay, so after the root, you have to go to the leftmost subtree. Okay, go to the leftmost node, and actually you have to traverse this left subtree, and then when you are done, then you go to the right subtree. Okay, so in the left subtree, when I reach it to the C, this is in itself the root, so I got to write it down, and then I go to its left, and now it is the leftmost, so write it down, because now this is the left, root left. Okay, so this is what we're saying, we go to the root. Okay, now go to the leftmost node, okay, from the root node, which is in a left subtree. Okay, then we have to go to the leftmost node, and we're going to write all of these. Okay, so what we say, that if it is a root, write it down, then go to the left, and this itself is a root, so write it down and go to its left. Now this is the left of C, so you can write it. Okay, now so A is done, C is done, E is done. So basically when we say here this was a leftmost, okay, node, we visit its parent, that is the C, and now it is done, so it's right, because the root left is done. Now it's right, because root left, right, so it's right, that is G. Okay, so we write it down because we have to write the root first, and now go to its left, that is this L perhaps. Okay, and now it doesn't have a right, so we go back, this is done, this is done, so left subtree is done. Okay, root is done, left subtree is done. Now A is right subtree. Okay, have to be traversed. Now we here, when we reach it F, this is itself a root of this tree, so we write it down. After root we will go to the N, so this is done, we go to the N, that's the left, so we write it down. Then we come back, now root left is done, now it's right. Okay, this is itself a root of this tree, so write it down. Now after root we need to find the left, there is no left, so go to its right, now write the M. This is the way we actually traverse this tree in a pre-order fashion. Okay, let's do more examples. So in this we will start from the root, so write the root. What's happened to this? Wait a second. So the root is the A is a root. Okay, so write it down, because we got a root left, right. So when it's a root, then go to the left, it is itself a root, write it down, go to its left, that is D. So this is done, this is done, this is done. Now in this case we are here at the D. Now go back, it's root and left is done, go to its right, so E itself a root, write the root, then go to the left, that is H. Now root is done, left is done, now go to its right, that is I. Now this left is done of the A, go to its right now. Okay, now this itself is a root, so go to the root, left, right, so that is C, F, G. Okay, so what we have to do is root left, right. So for example we have A, B and C only, so how we traverse this, A, B, C, that is first root, then left, then right. Okay, now when we have gone here, for example, now same thing will apply to the B, the root left, right. So if this, it has the left, it has a right, so do first the root, that is B, it's left and right. Okay, and so on. Do it recursively. Finish first the left subtree, then go to the right subtree. Okay, and the same way. Now, how to implement this? We can do it in a recursive manner or in an iterative manner. So we can, in iterative manner, we can use a stack, or you can do a recursive calls, and we can traverse it that way. Now, implementation we have already done. You can see the video of linked list representation of binary. Okay, here let me explain it again. So we have a node or record, okay, where we have a data part. This is the num, and we have a left pointer and we have a right pointer, which points to the left node, and this points to the right node, right? So that's why we have a left and a right pointer, and we have the data part. And in a preorder, okay, we have, you actually can create here a variable tr of this record type, okay, and of that type you have a pointer called root, okay, which will always, on top we have a root which always points to the first node, right? Okay, so we say that if root not equal to null, because what if you can traverse only if there is something. So root should not be null. Then what you do is you first, because root is pointing to the first node, so you print that root arrow num. Then next time you call the itself recursively, you are calling to itself, and you are sending the root arrow left, that is the left address, that's the address of this node, okay, into this. Now the root will hold, this root will hold for the next time, the root will hold the address of this node, okay. So if I say here print the root arrow num, that is this guy now, because firstly root was having this address of the first node. Now root is having the address of the left child, so it will print the data of the left child, okay, and it will do it recursively and so on. It doesn't finish the root, because it goes on root arrow left, okay, and then when it comes back it goes to the root arrow right. So that means now the root will have the address of the right child, and so on. I explained this in the linked list presentation of the tree, so you can see it there, okay. If you're not getting this iterative implementation, then you just watch the video on the linked list presentation of the binary. There you will get it exactly what is happening, okay. Now we move on to the iterative version where we use the stack. So in iterative version we're going to use stack. So let's do a couple of examples. This is our previous example. So what we do, we have a stack here, okay. Say this is a stack, okay. Now initially there's nothing in the stack, and we have a pointer p which is pointing to the a node, and we have a node like this, we know, which have a left child and the right child. Left has the address of the left child, and the right has the address of the right child, okay. So what we do firstly is we assign p to the first node, that is a, and we print it. Because it's a pre-order, we got to print the a. And when we are accessing the a, we will see what is its right child and what is its left child. Firstly, its right child is put on a stack like this, and its left child, actually p points now to the p arrow left, so p is gonna be p arrow left, because p was no, pointing to the root node. Now p points to the left node, that means p is pointing to this guy, okay. And it does the same thing to this guy, that if it has a so firstly it prints the root, that is the b, okay, and now it assigns its right child onto the stack, and its left child, now p becomes p arrow left. This thing happens, p becomes p arrow left, that is p is pointing to the d now, okay. So and since it's a root, so it will print it, so d is printed, okay. And now again p is equal to p arrow left, and here this kind of node will have a null in its left, and also it has a null on the right. So when p arrow left is so when it is there, so p arrow right has to be kept in a stack, and p has to be p arrow left, but there is null in it, so it will not put this in a stack, and p arrow left is null. So when this thing reaches that p arrow left is null, it pops one from the top, that is e, okay. So this e is popped, okay, on a stack, and p points now to that that node which is on a stack. Okay, so what will be E actually here? The address of this, the E. So P will point to that address now. So now P is pointing to E, and since it's an root, so it's gonna print it, and its right will be put. So E is no more here now. The stack is like this, C, and it put its right, that is I, on a stack, and P become P arrow left, that is P is pointing to the H. Okay, now since it is a root, so it will print it. Its right has to be in a stack, but it is null, so it's not gonna put in a stack. And its left, P will become P arrow left, so P will have a null. So P, because when P goes to P arrow left, that's the null. When that thing happens, we have to pop something from the stack, and P points to that. Now that is I, so P will point to the I now. Okay, so P is pointing here. Since it's a root, it will print it. Okay, and its right has to be on a no stack, and its left, P will become P arrow left. So since that is null, and there is null on this way, so nothing will be on a stack. So stack is now like this, because we have only C now, okay, on a stack, and P arrow left is null, so pop something from the stack, that is C. So C is gonna be popped. So C is popped, so P will point to that. Okay, and now P arrow right, that is G, is to be kept. Now stack is like this, it is empty, so G will be on a stack, and P will become P arrow left, that's P points to the F. Okay, now so you print the F, okay, here, and now what you do is P arrow right is nothing, and P arrow left is null. So when the P arrow left is null, you're gonna pop from the stack, that is G, so put the G, point P to the G. Okay, so G, and because it's a root, so no, print it, and you have to put P arrow right and P arrow left. P is equal to P arrow left, that is null, and since there is nothing, so you have to pop something from now stack is empty. Okay, you have to pop something from the initially you have put the null on the on the stack. Initially you got to put the null on the stack, so null is always there on a stack. Okay, so null is always there on a stack. So when there is nothing, there is only one thing, that's a null, and P will point to that. So P will be equal to null. So that will be the end of this algorithm. Okay, so when P points to the null, that is going to be the end of the algorithm. Okay, so this is how we do for the pre-order traversal in a non-recursive, in an iterative manner. Okay, let's do another example. Okay, now here in the beginning we have a pointer P, okay, which is pointing to the root. Okay, and in a stack in the beginning we have firstly the null on a stack, and P is pointing to the A. Now if it has a right, put that on the stack. Okay, and P will point to the P arrow left, that's P will point to the C, and in the meantime you have printed the A. Now because this is a root, you print it, and the right one, that is G, will go on a stack. Okay, and P will point to the E now, P arrow left, so that is E. Since it's a root, so print it, and its right has to be on a stack, because there is null, so you don't put it on a stack. And P arrow left is null. When the P arrow left is null, you actually point P to something which is on a stack, that is the G. Now P will point to the G here. Okay, so these are done, and now P is pointing to the G. Since it's a root, so it will print it, P arrow data, that is to be printed, and P will, its right, which is nothing, so you can't put anything on a stack, and its left, P will point to the P arrow left, that is P will point to the I. Since it's a root, print it, and P arrow right, there's nothing, P arrow left, there is null, so when there is a null, pop from the stack, because this is not on a stack now, G has gone, so only F is there, so pop the F. Okay, and point P to that. Now P is pointing to the F. Okay, and now it's right, that has to be on a stack, that's K will be on a stack, and P will point to the N, and P will point to the N, and it will print it, and there is null, P arrow left is null, so it will pop K from the stack and point P to that. Now and put M on a stack. Now stack will be having M only because this is popped. Okay, and P arrow left is null, so pop the M. Okay, and point P to that and print it. Okay, in the beginning we have the null, so null will be always there. So null is always there, right? So when you pop the m, we have only null here. So p is equal to p arrow left. Okay, it is null. So point p to the whatever is on the stack, that's null. So when the p is having a null, we will stop. We are done. So this is the pre-order traversal of a tree using iteration. Okay, hopefully you got it. So this is the end of this segment. Okay, and see you in a next video with the post order traversal. Until then, ma salama.